Good day, students. Today we want to look at the basis of electrolysis. Now, in chemistry, biology, even in physics, you often have terms or words that have this suffix lysis. Okay, so lysis is a Greek term which means to split up. Okay, you are splitting up substances. You can have hydrolysis, breaking down of a chemical bond, and water is involved. Catalysis, the speeding up of a chemical reaction due to the presence of catalyst. So whenever you have this word lysis, it means you are splitting up. But today we are going to talk of electrolysis, okay? Meaning to say we are going to split up an ionic substance, but that splitting up is going to be facilitated by the presence of an electric current, okay? So electrolysis, we can say this is the breaking down of an ionic substance using electricity. Okay, so two keywords here that we're supposed to take note of. We are breaking down an ionic substance. Okay, meaning to say, if we use covalent substances, we may not succeed in our electrolysis. The substance that we are going to break down should be ionic, meaning to say it must possess ions. Okay, there are key terms that you are expected to understand as a basis, as a foundation, because electrolysis is common both at IGCSE, which is your O-level, and also in advanced or AS A-level chemistry. So today, I'm just going to touch on the important terms that we are supposed to look at when we are discussing electrolysis. Okay, the first term that you are supposed to know is electrode. Okay, electrode. Okay, electrode, you are referring to the rod. Okay, this rod could be a metal or it could be a non-metal such as graphite. Its purpose is to carry current into and out of the electrolyte. Okay, so as we write down terms here, it would be better for us to just label the diagram so that we'll be in a position to understand what we are talking about. Okay, right. Now, if you focus on this diagram, you're going to find out that there is a power source. Okay, this is a power source which is labeled as positive and negative. That's our power supply. Okay, our power supply will have a positive end, and the positive end has an electrode which is responsible for transmitting current into our electrolyte. Okay, so our positive electrode, we are going to label it as anode. Okay, right, so our positive electrode, let me put it down here, and then I label it as anode. Okay, but we also have our negative terminal. If you trace, it's also connected to another rod. We call this one cathode. Okay, it's very, very important for you to understand that the cathode is connected to the negative terminal of our power supply, and our anode is connected to the positive terminal of our power supply. Collectively, our cathode and our anode, these two give us the electrodes. They are called electrodes. So we have two types of electrodes. Either an electrode could be positive or an electrode could be negatively charged. There is no harm if you indicate our electrode here is connected to the negative terminal, and this one will be positively charged. Okay, so we have cathode and the anode. Okay, now we have the liquid. Okay, the liquid or the compound which we are going to break down. This one we are going to call it electrolyte. Okay, electrolyte. So the substance that we are going to break down, we're going to call it electrolyte. Okay, cathode, anode, electrolyte, electrode. Okay, now when you look at what is happening inside here, okay, we are going to have an ionic substance. Okay, we are going to have an ionic substance. I'll just take an example of lead bromide. okay? Lead bromide, Pb is positively charged and Br is negatively charged, okay? Now, what's going to happen here is when you have molten lead bromide, okay, the ions are free to move around the electrolyte, okay? Now, you are supposed to remember that your lead is positively charged. So the lead is going to be attracted to the cathode. Why? Because it's positively charged. The bromide ion is negatively charged, so it's going to be attracted to the anode. Okay. Now, let's write it here. The Pb plus is going to go to the cathode. Okay. And the Br minus is going to go to the anode. Okay. It's going to go to the anode. Now, you should then use or link this to the names of these ions, okay? Right? You should be in a position to link what is happening here to the names of the ions. Now, remember, all positively charged ions are called, we call them cat ions, because they go to the cathode, okay? I'm just saying it's split so that you'll be in a position to remember it, okay? Lead, even other positively charged ions, they go to the cathode, and we are going to give it a name like cat ions, okay? And negatively charged, they go to the anode. No wonder why their name is like this. It's an ion, but it goes to the anode. That's where these names would come from. And I suppose now it's clear as to why we have two types of ions. Some are positively charged, some are negatively charged. During electrolysis, they migrate differently. Those positively charged ions, they go to the cathode, okay? Why? Because unlike charges attract positive and negative and positive. So that migration is caused by the fact that they are of equal or oppositely charged ions. Okay. So remember, students. Okay, these names actually can also be derived from the process of electrolysis. Okay. For our exams, I'm just going to write something in the box before I end. For our exams, I'm just going to write something in the box before I bring the session to an end. Okay, just one exam tip for today, okay, for electrolysis. Whenever you get a question on electrolysis, do not panic, okay? Do not panic. Why am I saying that? Don't panic because positive is anode, but negative is cathode, okay? So that is just one way of remembering. Do not panic when you get a question on electrolysis. Why? Because your positive is anode, but your negative, okay, your negative is cathode. So I usually have that abbreviation, panic, okay? Positive is anode, negative is cathode, okay? This is the foundation of electrolysis. You need to know terms like cathode, electrolyte, electrode, okay? And you also need to know the basis of what happens as we carry out electrolysis. All our electrodes could be either a metal or a non-metal. And the characteristic or the property which is important for our electrode, it must be a good conductor of electricity. So a metal can be a good material to be used for that. And also non-metals such as graphite can also be used to perform the purposes of having electrode. Okay? I thought that we should just have the foundation for electrolysis today so that in other sessions to follow, we are now going to start from somewhere. Having this foundation, we are now in a position to build on what happens when we are doing electrolysis of molten substances and also when we are doing electrolysis of aqueous substances. As long as you've understood the best of electricity and also electrolysis, you should be good to go. Thank you, students, for this session and for listening to this session. Remember, if you like this session or if you like other videos on my channel, please remember to subscribe so that you'll be in a position to increase the visibility of this channel, and also share with your friends as you are involved in discussion groups. Remember, time moves very fast. Very soon, some of you are going to be writing May, June exams, and some will also write October, November exam. But this session is just meant to give you a foundation to electrolysis. Thank you. Bye-bye for now.